Okay, so in this video, we're going to look at, so in this module, we're going to be working with quadratic functions. All right, now our very basic quadratic function, the f of x is equal to x squared, is one of our toolkit functions. Right, meaning it's a very common function you see we'll be working with a lot, and it's a polynomial, so it's kind of our first introduction into our polynomial. Well, technically second, since you can consider a line to be also a polynomial. But we can think of the quadratic as one with a little more character in terms of its graph, right? And as you can see here, right, what we have in front of you is that the graph of any quadratic, right? The graph of any quadratic is this kind of U shape. Okay. And this U shape is what we call a parabola. All right. Now, if you see here the equation that I have written here, so it's a quadratic, the highest power is squared. So any polynomial with the highest power that is 2, right, it's going to have this general shape of the graph, right? Where A, B, and C, they're going to be real numbers, right? Depending on what they are, that will affect the shape of the graph. Right? Now, what we have in front of you here, right, I have a parabola, but I also have several points of interest that are labeled there. And now as we progress, we'll go more in depth into how to find each of these, right? As you can probably see some of the notation on the equation bar. Maybe some of those formulas look familiar or not, but there'll be plenty of time to get into how to calculate these values. Here I just wanted to introduce you to the general shape of the graph here. As we could see, this general U shape is what's called a parabola. Some characteristics that are going to be of interest for us are the x-intercept, as you can see labeled here, these points. And actually, let's see here. Can make a little, stand out a little more, right? So here, the x-intercept, the y-intercept, right, as you can see, right, self-descriptive x-intercept where it crosses the x-axis, or when is y equal to 0, the y-intercept where it crosses the y-axis, or where the x value is equal to 0. All right, now another point here that we're going to be after that's of interest is called the vertex. As you notice in this case, it's a minimum point, right? It's kind of where you can think of it decreasing, it reaches its minimum, and then it goes back to increasing. Okay, now depending on the value of A, maybe it has a general shape where it looks like this. All right, now in this case, it increases, reaches a maximum as opposed to a minimum, and then it starts to decrease. All right, and as you can see, as I play around with the values of what B can be, that affects the shape of it, right? Okay, so sometimes you could see, all right, as we could see here, sometimes we'll have no x-intercepts, but we'll always have a y-intercept of some kind, right? We can always set x equal to 0, right? Something it might be, the y-intercept might be the origin, but it's still a y-intercept. What we're not guaranteed is to have x-intercepts, right? Sometimes we might have 0, sometimes we might have 1, right? Where the vertex will lie right on the x-axis, but sometimes we'll be in the case where we'll have 2. Okay. All right, so just keep that in mind as you kind of go through your studies here. All right, that the x-intercepts, there's different possibilities. All right, and another thing that we see here from this graph is this dotted line. All right, and notice it's labeled with the axis of symmetry. All right, also notice that it goes through the vertex, right? No matter how I change the shape of my graph here. All right, no matter how I change the shape of my graph, I still have this axis of symmetry going through the vertex. The way you want to think of that, if you use that line to kind of fold your graph, you have a mirror image of the graph across that axis of symmetry. Hence its name, axis of symmetry. All right, so it's kind of the graph is reflected across these values here, right? Here and here. Okay, so these are the characteristics of the graph of a quadratic, and like I said, any quadratic is going to have this general shape of a parabola, whether it is opening downward in this case, where we have a maximum value, or opening upwards. In this case, we have a minimum value. And again, the x-intercepts will vary, maybe 0, maybe 1, maybe 2. All right, and we'll always have a one y-intercept. Right? Exactly one, since this is a function, right? If we had more than one y-intercept, that would violate the rules of it being a function, and quadratics are, in fact, functions all the time. Okay, so here we have our general formula quadratic. Later, we'll introduce the vertex form, standard form, right? And we'll look at in depth into how to find all of these different quantities, right? That be the x-intercept, the y-intercept, a vertex, or the axis of symmetry. Okay, thank you.